The inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At a height of h, the radius of the funnel is given by 1 over 20, 3 plus h squared, and that's for the h's between 0 and 10. Units are inches. Okay, find the average value of the radius. Okay, so for part A, since the interval goes from 0 to 10, we will do the 1 over 10 integral from 0 to 10 of the r function, r of t dt. So in other words, we need 1 over 10 times the integral from 0 to 10 of 1/20th 3 plus h squared. Oh, whoops, so that's dh, my bad. The radius is in terms of h. r of h dh. Okay. 1/20th can be pulled out in front as a constant, so we have 1 over 200, integral from 0 to 10, 3 plus h squared dh, and then notice that the antiderivative of 3 is 3h, and the antiderivative of h squared is h cubed over 3. So if we were to evaluate these between 10 and 0, that means we would get an answer of 1 over 200, 3 times 10 is 30, plus 1,000, 10 cubed over 3, and then there's no need to evaluate at 0 because when we insert h for 0, we're going to get 0. Remember that these are inches, so since this is an average value, that means our units here will be inches, and that is the answer to the average radius of the funnel. Excellent. Okay, moving on to part B. B asks us to find the volume of the funnel. Okay, the volume of the funnel means we need to add up all of these circles now, right? So we're going to have to add up for part B. We're going to have to add up from the height of 0 to 10 pi r squareds, right? So pi times 1 over 20 3 plus h squared squareds, right? Pi r squareds are the area of a circle, dh. Okay, so quickly right off the bat, I'll pull out the 1 over 20 squared, which is 1 over 400, and the pi. So I can say pi over 400 times the integral of, now we need to do 3 plus h squared, so let me write that as 9 plus 6h squared plus h to the 4th dh, and that's still from 0 to 10. So now we have pi over 400, antiderivative of 9 is 9h, for 6h squared we'd have to go to an h cubed, dividing by 3 on the 6 would give me 2, and then we'd have this h to the 5th over 5, and that's on the interval, again from 10 to 0. So it looks like our volume is going to be pi over 400. 9 times 10 is 90. 10 cubed is 1,000, so plus 2,000. And then finally, let's see, that would be h to the 5th would be, let's just write it as 1, 2, 3, 4, 5 over 5, right? And since it's the AP exam, we don't care about the arithmetic as much as we care about the algebra and the calculus, which we have performed correctly. The units were inches, so as a volume, this would be inches cubed. And truthfully, I would not do any more simplification than that. Okay, final part. Part C has us do a fancy related rate problem. Okay, yeah, that's no problem. So we have up here that in part C, r is equal to 1 over 20, 3 plus h squared. We're simply trying to figure out what is dh dt. So I'll take the derivative of both sides with respect to time. That would imply that dr dt is equal to 1 over 20 times the derivative of 3 plus h squared. Derivative of 3 is constant, so that's 0. And this becomes a 2h dh dt. So in other words, dr dt equals h over 10 dh dt. The problem says that the radius is decreasing at a rate of 1/5. So the dr dt is -1/5. We're trying to do this at the moment when h equals 3, so that gives me a 3/10 dh dt. Oh yeah, no sweat. So then that just means that dh dt, when we multiply over by 10/3, would be -1/5 times 10/3, which is -2/3. And since that's the height that is changing, the units would be inches per time unit, seconds. So the answer is -2/3 inches per second.